types of agent, and we will try to see these types of agent and how things are being worked upon in these types of agents. So we'll start first with the reflex agent. So as we see, the reflex agents, they are the program selection uh, which is based on the actions of the current percept. So the reflex agent basically uh, take actions based on the current percept which is given across to the program. So they are the simple set of programs which are easy to understand and which can be worked upon. So reflex agents are very simplified uh, level of programs which works across in the agent and try to take the current perception, try to take actions based on that. So that's an example of the reflex agent. So the examples of reflex agent, as we call, is the central heating systems, your overheating systems, your program selection, which happens through the actions to switch off the power. So they are few of these examples of a reflex agent. So based on the current percept, your program instantiate the action and the overall actions do happen. So that's an example of reflex agent. So the next type of the agent world is your model based reflex agent. So in this, the agent has a model of the world. So there is a view of the world which has been created, and your agent try to work up based on that. So in the model based reflex agent, obviously there is lack of sensors. So there is no sensors which are available for the agent to intercept the percept. So the model of the world which gets created inside, they try to make it up for it. So can the model based agent uh, make up for the lack of sensors, because the virtual world doesn't need the sensor data, it doesn't require that across. So your program now looks at the percepts and then it tries to update its own internal state, internal world, and then as program can access the possible actions in the future states, it uses the reflex agents approach to determine what actions has to be taken across. So in the model-based reflex agent, there are no sensors which are given across to the percept, but then the model of the world is there, which helps the program to take the actions based on it. So as you see the example for the model-based reflex agent can be the underwater vehicle system, which can say loses the visual sensors out of because of the way, because various kind of silt, because of not having enough light. So your underwater vehicle losing the visual sensor is an example of a model based reflex agent. And they try to use the 3D mapped geometrical model for carrying out the task. So the underwater vehicle without having visual sensors continue the journey inside the water with the help of 3D mapped geometrical model is a perfect example of model based reflex agent. Now the third part or the third type is your goal-based agent. So the goal-based agent is fundamentally aimed at working when there is some specific goal which has been assigned to the agent. So in the goal-based agent, your program need more than just sensors and internal world. So they need sensors plus internal world, plus they also need certain agents functionality. So they need certain goals. So your agent requires certain set of goals, which agent will work to fulfill around. So your agent will work to meet the specific goal which has been assigned to it. So these programs are, as we call them, more flexible and they are more versatile because they can adapt to the respective changes which is coming around the world. So these agents are more evolved because they work on a respective goal and they try to work and deliver the goal which is assigned to them. So the examples of goal-based agent, some of them are the autonomous vehicles which can choose one of those five exits in a highway. So the goal which you can feed it to the autonomous vehicle is the route has to be safest, the route has to be quickest, the route has to be most scenic, shortest, and the overall cheapest. So these are the kind of goals which you assign to your autonomous vehicle when you are traveling on a highway, and based on these goals your autonomous vehicle try to take the shortest path, you try to take the safest path or the quickest path based on these goals being assigned to them. The last, the last type of agent, as we call it, is called utility-based reflex agent. So utility-based reflex agent is again a highly evolved type of agents. So if we call utility is the scientific way as economists measure the agent's happiness. So utility-based agent is again one of the most evolved way of carrying out the task. It's more versatile than simply saying yes or no, or are you happy or not. So it measures how useful it is, right? So there are various tasks which can be handled with the likes of utility-based reflex agents. So the various chatbot doctor, they try to assess the overall efficacies of the treatment which is given to the patient needs. So they are the examples of utility-based reflex agent. So in this, the overall work done by the agents are uh, based on the kind of treatment which is given across to the patient. So it's not only based on the goal, but then it's based on the kind of utility which your agent delivers by helping solve problems of uh, patients by treating them across. So as we see, obviously what was missing in all these types of agents, the critical piece which is missing from all these elements was learning from experience. So till this point in time, whatever we have discussed for the agents, your agent take the actions based on the various goals assigned to it. Agent take the actions based on the various utility functions which is assigned to it. But then the learning from experience part is missing from all these aspects. So now let's try to again relook to the Russell and Norvig general learning agent model, how it is working and how it looks. So we have the external task environment, which provides the percept, and then sensors, which is there inside the agent. They try to take those percepts. In agent, you have the elements of critiques. So it's the critique which capture the input from the agent and then try to provide the feedback to the learning element. So learning element is basically responsible for learning and overall improvement of the agent. So there is exchange of knowledge happening in the or through the learning element with the overall performance element associated with it. And then there is a learning goals which is provided across through the problem generator, which feeds back to the performance element. And finally, the performance element provides the actuator the kind of output which has to be actioned back to the external world. So you have critics, you have learning elements, you have performance element, and you have problem generators. So these are the important aspects which has to be considered when you are trying to have a journal learning agent. So your learning element is responsible for overall learning and improvement. Your problem generator is responsible for making any kind of suggestions for exploratory work, and that's how your sensors and actuators work in agreement with the overall agent for the output and for the inputs which is received through the percept and the output being delivered by the actions to the external world. So, so now let's try to see what are the different states of the agent world. So how can we represent the world that support the making of these models? So we will, as we go down, as we look into further, the overall fidelity rates improves. So the highest state, as we call, or maybe the basic, or let's say the fundamental state, as we call, for the agent world, is the atomic state, which is like a black box, and we don't have any view of the internal structure. So that's an atomic state of the agent, which is all about putting the things in form of a black box. There is no view of the internal structure presented across as a part of it. The second state, as we say, is called your factored state, which is list of factors in terms of the attributes being made up of Boolean, and then there is a real value which is put across in form of fixed set of states. So in the factored state, you try to capture the vector list of attributes, and then you try to work out based on that. And the most evolved state, as we call, is called the structured state, which is made up of objects, wherein uh, you try to establish the relationships with the objects, and then it is the highest evolved state of the agent. And we as a human basically use the structured state for establishing any kind of relationship with the kind of objects, and then we try to have our learning basically done based on the structured state. So let's try to see what are the typical agent functionalities which are performed by agents. So the given inner agent representation of the world, what type of actions or functionalities would our agent need? So what agents will be working on from the perspective of the external world? So agent try to carry out the planning based on the inputs being received across. They ensure the searching part of it. So how the multiple agent will be working in case they are working on assignment of working with adversaries, or they are trying to work on assignment of finding the best route, or they are working on assignment of doing a navigation, or if there's any kind of multi-agent games, or the games of chances or rolling dice. So there are elements of searching being carried out by the typical agent as a part of the functionality. The next important aspect which agent do as part of functionality is your natural language processing. So how they process the natural language, the inputs which is received by the agents from the external world in form of the natural languages. And then the next important functionality is representing the knowledge, managing and handling the knowledge, trying to make the decisions based on that, and then overall learning from the examples. And then finally creating the perception based on that. So these are the typical a few functionalities which agents carry out in form of planning, searching, doing natural language processing, representing the knowledge, making the decisions, learning from the examples, carrying out the overall perception, and finally delivering the output. So these are the high level functionality being delivered. So now let's try to see how machine learning acts as a part of the overall AI toolkit. So machine learning, as we say in a theory or in a practice, is how the overall computers learn from the data without being programmed explicitly. So how, and as we have already talked and discussed about the Tom Mitchell's definition, so your machine learning algorithms have to learn from the experience when they try to carry out the set of tasks over a period of time. The overall learning happens. So there is no external programming being done for making your machine learning algorithms learn. So the most important things are how computers learn from the data without being programmed explicitly. And as we also look and see, it's also useful to understand that how the likes of big data, Internet of Things, and various other elements, which are the use cases of machine learning uh, is enabling and interacting with each other. So big data is certainly playing a great role in terms of feeding the data to the machine learning algorithms. Similarly, the Internet of Things is one of the ways by which the interaction happens and the data get generated, and then that data get fed across to the machine learning algorithm. So spam filtering is one of the great use case. Image analysis is another use case. The research use cases, being used by various researchers and various people in the R&D area. Similarly, in engineering and in medical field as well, machine learning algorithms are also being useful in delivering the value to the society. So as we say, defined by the type of learning it undertakes on data, we are considering from the perspective of learning from the example. So how things learn from the example. So there are various free open sources and transparent systems for the machine learning algorithms, which have the functionality, software, the hardware, and we can certainly start picking up some of those algorithms and we can start working on it. So it is always popularity is always important to start analyzing from the large data set. So ensure that how we pick up from the large data set, how the business analytic function works across, and how we deliver overall value. So as contrast to the AI examples, your home automation, your robots, your home assistants, your chatbots, your smartphones, and the smartwatches are some of these examples of ML based algorithms and ML based output.